Welcome to Matri Academy. Let's start chapter 10 Enzymology. The term enzyme was coined by F. W. Kohner in 1878, which means in yeast. Most enzymes are proteins in nature. Exception is ribozyme, which is RNA having enzymatic activity. Enzymes are generally globular proteins. Ribozyme, also called RNA enzyme, RNA molecule that is having enzymatic activity or which catalyzes a chemical reaction is known as ribozyme. In 1967, Woos, Crick and Origel for the first time suggested that RNA could act as a catalyst based on the findings that it can form complex secondary structure. The first ribozyme was discovered by Thomas R. Ketch in 1980s, who was studying RNA splicing in the ciliate protozoan Tetrahynema thermophila. They have divalent metal ions such as magnesium as cofactors. They also catalyze the aminotransferase activity of the ribosome. Many natural ribozymes catalyze either their own cleavage or the cleavage of other RNAs. They catalyze two types of biochemical reactions, that is the cleavage of phosphodiester bond RNase P group 1 and group 2 introns and synthesis of peptide bonds, that is the peptidyl transferase. RNase A. RNase A or ribonuclease is a group of enzymes that catalyze hydrolysis of phosphodiester bond in RNA molecule. Then the lysozyme, discovered by Alexander Fleming in 1922. Its structure was given by Phillips in 1965. Lysosomes found in a number of secretion, tears, sweat and egg white. It cleaves the beta-1,4-glycosidic bond between N-acetylglucosamine and N-acetylmuramic acid of peptidoglycan cell wall. The protein nature of enzyme was established by crystallization of urease enzyme by J. Summer in 1926 and demonstration of a correlation between the enzyme activity of crystalline proteinase and their protein content was done by J. Northrop and M. Kundin in ICR question asked in JRF 2003. The first amino acid sequence for an enzyme is ribonuclease was reported in 1963. How many groups or classes have been classified? That is the 6. Question asked in ICR JRF 2001. It is short form is OTHLIL. Oxidoreductase, transferase, hydrolase, lyase, isomerase and ligases. X-ray structure of an enzyme lysozyme was elucidated in 1965. Lock and key model, rigid active site model was given by E. Fisher. Induced pit hypothesis, flexible nature of active site was given by Coastland. Catalytic enzyme complex, holoenzyme is formed by the apoenzyme and coenzyme. Non-protein group of a conjugated enzyme is known as cofactor, which is required for biological activity. Then that 1 calorie is equal to 4.185 into 10 to the power 7 ergs, 1 joule is equal to 10 to the power 7 ergs and 1 calorie is equal to 4.185 joule. The change in energy of a system depends only on the initial and final stage and not on the path of transformation. If delta G is negative, the process is spontaneous or exergonic. If delta G is positive, the process is endergonic, stable but not spontaneous. If delta G is 0, the process is in equilibrium. Del G is measured in kilocalorie per mole. For the occurrence of a spontaneous process, del G, free energy change, should always be negative. ICR JRF 2000, 2001 and CSIR December 2003 question. Enzyme urease contains nickel. Coenzymes are derived from vitamins. NADP is an electron carrier. Loss of electron is known as oxidation. For every 10 degrees centigrade rise in temperature, the rate of reaction gets double. This is also known as Van 't Hoff's rule. Over a range of 0 to 40 degrees temperature, the quitin, the quotient coefficient for an enzyme controlled reaction is 2. Enzyme catalyze increase the rate of reaction by lowering down the activation energy. Enzymes change only the rate at which equilibrium is achieved. They have no effect on the position of the equilibrium. Enzyme catalyzes the formation of transition state. Enzyme catalyzed reaction can exhibit zero order kinetics when the concentration of reactants are so high that the enzyme is completely saturated with reactants molecule. Next one, enzyme unit. The amount of enzyme causing transformation of 1 micromole of substrate per minute at 25 degrees centigrade under optimal condition of measurement. Cattle. The cattle is the accepted SI unit of enzyme activity. 1 cattle is that amount of enzyme that catalyzes the transformation of 1 mole of substrate per second. 1 unit is equal to 16.67 nanocat. Enzymes showing feedback inhibition are known as regulatory enzyme or allosteric enzymes. And many allosteric enzymes show cooperative effect, that is, binding of a substrate molecule to an enzyme molecule promote the binding of more substrate molecules to the enzyme molecule. Allosteric enzymes have sigmoidal graph or curve when V is plotted against S. The sigmoidal kinetics was explained by Monod, Wyman and Changiux, that is called MWC model in 1965. For normal enzymes, the V and S plot is generally hyperbolic. Example for myoglobin. For allosteric enzyme, it is sigmoidal. Example for hemoglobin. So, hyperbolic for myoglobin and sigmoidal for hemoglobin. Michaelis-Menten invested in inverse catalyzed hydrolysis of sucrose. The equation is V is equal to Vs by Km plus S, where V is the maximum velocity at saturating substrate concentration and S is the substrate concentration. Then about the Michaelis-Menten constant Km. Km or Michaelis-Menten constant explains the rate of reaction at which half of the reactants are converted into products. Question asked in ARS Net 2001. Concentration of substrate at which reaction velocity reaches half of its maximum velocity is called Michaelis constant. Km is equal to K1 plus K2 by K1. If the ratio of constant K1 plus K2 by K1 and is expressed as mole of substrate per liter, lower value of Km describes the greater affinity of the enzyme for the substrate. In the equation, reaction velocity Vmax versus substrate concentration shows the hyperbolic plot. The interpretation of Michaelis-Menten's model were defined by Briggs and Halden by an assumption termed as the steady state assumptions. Km is equal to the substrate concentration at half of the maximum rate. Km represents the substrate concentration at which half of the enzyme active sites are filled by substrate molecules. Turnover number. Turnover number of an enzyme is the number of substrate molecule converted into product by an enzyme molecule in a unit time when the enzyme is fully saturated with the substrate. The term kcat represents the kinetic efficiency of the enzyme. Its unit is second minus 1 or second inverse. Specificity constant. If the ratio of kcat and km, it is the ratio of kcat and km. It is widely used as measure of enzyme efficiency or enzyme effectiveness. Next, the Line-Weaver-Burke plot. In Line-Weaver-Burke plot, 1 by V is plotted against 1 by S. And the equation is 1 by V is equal to Km by V into 1 by S plus 1 by V. So, Y minus intercept is equal to 1 by V or X intercept is equal to minus 1 by kilometer. Hence, slope is equal to kilometer plus V. The acid-salt ratio to be used in a buffer is given by Henderson-Hasselbalch's equation. Question asked in ICAR JRF 2003. Then the types of enzyme inhibitors. Competitive inhibitor. In case inhibitor competes with the enzyme for the active site, not with the enzyme substrate complex, the form enzyme inhibitor complex, no product formation take place. In competitive inhibition, if substrate concentration is increased, then the rate of reaction increases. Question asked in ARS 2013. Raise Km and exerts no effect on Vmax. ICAR JRF 1999. Example, malonate is a competitive inhibitor of a succinate dehydrogenase. Question asked in ARS 2001. Sulfa drug compete with para-aminobenzoic acid in bacteria. Then non-competitive inhibitor. Inhibitor may compete with the enzyme or the enzyme substrate complex. In this case, the Vmax decreases. In the competitive inhibition, there is no effect on Vmax, but in the non-competitive inhibitor, there is a decrease in Vmax. Then next, uncompetitive inhibitor. Inhibitor compete with the enzyme substrate complex only. In this case, both decreases Km and Vmax. Both competitive and non-competitive inhibition types are reversible in nature. Idiostate is an example of irreversible inhibitor. Mercuric chloride and nerve gases are the example of irreversible inhibitor. Then the isozymes. Multiple forms of an enzymes that catalyzes the same reaction but differ from each other in their amino acid composition and substrate affinity, Vmax and regulatory properties are called isozymes. Example, lactate dehydrogenase exists in 5 different forms. Zymogen, an active precursor of an enzyme, is called zymogen. Magnesium is required as a cofactor for kinase and zinc for alcohol dehydrogenase, carboxypeptidase and carbamate dehydratase. The most popular dehydrogenase in living organism is glutamate dehydrogenase. Nitrate reductase is a flavoprotein containing FAD, cytochrome B and molybdenum. Ubiquinone is also called as coenzyme Q. Oxygen saturation curve for myoglobin is hyperbolic and for hemoglobin is sigmoidal. Milk curdling enzyme is obtained from Lactobacillus lactis, ICR JRF 2003. Substrate for aldolase enzyme is fructose 1,6-bisphosphate, ICR JRF 2003. The enzyme catalase requires ferrous for its activity. Elements required for the activation of enzyme ecotinitase is iron. The enzyme classified as hydratase catalyzes the cleavage of substrate molecule. Match the following. Kinase is a transferase, DNA polymerase is a ligase, aldolase is a lyase, protease is a hydrolase and dehydrogenase is oxidoreductase. Then again urease, the main component is nickel, cytochrome oxidase copper, arginase manganese, hexokinase में cofactor है manganese and catalase में important cofactor is ferrous. So all are these about the enzymes and their short notes and their quick revision. So let's tune to my channel, always like and subscribe so I get motivated to just promote my videos and to make new videos for you. So let's tune to my channel. Thank you for being here.